will compute but return only a single value. Let's take a look at a typical syntax for a window or analytic function. So this is what the syntax looks like, and I'll try and explain as much as I can. The window, so we have the window function, and then we have the arguments, first argument, second argument. So this is the window function. You can use any built-in or user-defined aggregate function as a window function. In addition to that, you can use PostgreSQL built-in window functions. So PostgreSQL has some built-in functions such as row number, rank, dense rank, and so on. I'll be explaining that in the next slide. And here we've got the over clause. The over basically is very instrumental. This is what makes the whole thing analytic. So what the over does, it determines the partitioning and the ordering of a row set before the associated window function is applied. All right. So the over clause defines a window or user specific set of rows within a query result set. Yeah. And then the window function will compute a value for each row in the window. The partition by here, this partition by is basically used to divide the rows into groups or partitions. If you omit the partition by clause, what will happen is that the whole result set is then treated as a single partition. So if you want to partition things or divide things, best to use a partition by, or the function will treat everything as a single partition. Next here we have the order by here. This order by clause basically is used to sort the rows within a partition. So what happens? The window function will process the rows in the order specified by the order by clause, especially for the window functions that are sensitive to the order. Okay, because there are Windows functions such as the first underscore value and the last underscore value and so on. So if you have Windows functions like that, then the order by is important in the expression. So let's take a look at some common Windows or analytic functions. We'll be covering each of them in separate lectures. I just want to highlight them here. So we've got the row number, we've got the rank, we've got the dense rank, the first value, the last value, and then we've got the lag and the lead functions. So we'll be covering them in separate lectures. Thank you so much for your time. Take care and bye for now. Hello and welcome. In this lecture, I will be creating a couple of sample tables that I'm going to use to illustrate how the analytic window function works. I haven't got any suitable tables at the moment, so that's why I'm going to create some sample ones. The queries I'm going to use will be available for you to download under the resource page for this lecture. So I've got a couple of queries here that I'm going to use to create a couple of tables. So I'm going to create two tables. One is going to be called product underscore groups, and the other is going to be called product. So basically it's going to have group ID as a column. You've got the 0 basically gives it automatic numbering, and that's going to be the primary key. And then we've got a group underscore name with the voucher data type. Not null means that's a constraint. That means that field cannot be empty. So here the same thing, we've got the serial for the data type, which gives it automatic numbering. We have the price in decimal data type. We've got a group underscore ID column. Again, here we've got a foreign key called group ID. Foreign keys basically means it has a corresponding, is related to this table. Okay, so let's go ahead. I'll create the first one. I'll highlight that and click on this lightning bolt, and that should create. Make sure you're creating the table in this DVD rental database. So make sure you're inside your query tool, make sure it's highlighted DVD rental. So it will tell you what database you're creating the table on, because it will highlight the name of the database there. So it tells you query returned successfully. Let's run the other query to create the second table. I'll click on the lightning bolt, and you can see it's created two tables. So we now have two tables. So let's come down here to the DVD rental and refresh the list of tables. We should see the two tables we created. Let's check that out. You see product groups and product. Excellent. So the two tables are there. The tables are empty at the moment, so I need to insert some sample data. Again, the sample data will be available for you to download under the resource page for this lecture. All right, let's insert some data into the products under groups table, which is this table here, and these are the values. So I'm just going to highlight that and click on the lightning bolt, and that will tells me it's inserted 3 rows. So let's insert some data into the other table, which is the products table. So this is these are the columns, and these are the values I'm going to load into that table. So I'm going to highlight it. The reason I'm highlighting it because I've got other queries in the editor, so I don't want them all to be executed, just the one I've highlighted. So I click on the lightning bolt, and that would say it's inserted 11 rows or records into the table. Okay, let's quickly query the tables and just to check that they have got some data. So I'm going to query this table here called products. So I'm going to highlight that query and click on the lightning bolt. Excellent. So we've got 11 rows in that table. That is good. Let's try the other query. Select that and click on that. Excellent. We've got 3 rows in that one. So we've got some data in both tables. So I can now begin to illustrate with analytic functions. Before I wrap up this lecture, I just want to do a quick test on using an aggregate function so that you have a clear understanding the key difference between an aggregate function and an analytic function. So before I start illustrating with analytic, let me quickly run through with an aggregate function. So the aggregate function I'm using here is AVG. So I'm selecting the price from this table here, the table called products, which is this table. If I expand the column, there is one for price. So I'm doing an AVG, I'm computing the function, running the AVG function on the price column, which is from the products table. So this will return, it will work on all the rows, but it will only return a single value, which is the key difference between, you can see it's returned just a single value. When I start illustrating with analytic function, you will see that analytic functions can perform the same calculation, but will return multiple, return multiple results in comparison with the aggregate function that returns just a single output or a single result. So that is it for this lecture. We've got our table set up. We got some sample data in. So we'll start illustrating with some analytic function from the next lecture. Thank you. Bye for now. Hello and welcome to this video. In this video, I'm going to illustrate how to use an AVG aggregate function as a window function. In the previous lecture, I illustrated a simple AVG function, which is an aggregate function. So this is the query I use. So I'm going to run that again so that you can see that an aggregate function returns a single value. So it will perform the function on all the rows within the table, but will return a single result value. An aggregate an analytic or window function behaves in the opposite direction. It will perform the same calculation, but can return multiple values or multiple rows. So in this query I've added here, the query is going to return the product name, the price, the product group name, along with the average prices of each product group. So in the query, the AVG function here is working as a window function that operates on a set of rows specified by the over clause. So what that means, each set of rows is called each set of rows is called a window. So this over here is what gives this query an analytic edge. So we are getting the data from this table called products, and we are doing a join, a simple inner join with this table called products underscore groups, using the group ID from that table. All right, so let me highlight this, run the query, so you can see the output. You can see in comparison with the aggregate function, this has returned, you can see multiple values for each group. So what actually happens behind the scenes, PostgreSQL will sort out the rows by their values in the group underscore name column. The partition by will then group the rows into groups. Then the AVG function calculates the average price for each product group. Okay? A window function will perform calculation on the result set after the join, or in cases where you have the where, or the group by, or the having clause complete. Okay, so it will do all that, but also before the final order by clause. So if you've got several order by clause, the window function will kick in before the final order by clause, but it will do so where there's a join. After the join, once the result has been calculated after the join, or where there's a where clause, or where there's a group by clause, or a having clause. Once all that is completed, it will then apply the window function. So that's it for this lecture on using the AVG aggregate function as a window function. In the next lecture, I'm going to take a look at the row number function. Thanks for watching. Bye for now. Hello and welcome. In this lecture, I'm going to illustrate how the row underscore number function works. So what is the row number function? What does it do? The row number function basically allows us to assign numbering to the rows of the result set data. So it will assign a running serial number to rows in each partition. So I've added some query here to illustrate how the row number function works. The row number function basically is going to assign a unique integer to each row in a result set. So let's quickly take a look at a basic syntax for the row number function. So this is what the syntax looks like. So it will use this syntax to assign integer values to each row in a result set. The set of rows that the row number function operates on is called a window. So the partition by, this clause will divide the window into smaller sets or partition. Okay, but if you don't specify the partition by clause, the row number function, the row number for each partition will start with 1 and increment by 1. That is if you don't specify the partition by clause. Because the partition by clause is optional to the row number function, you can omit it, and the row function will then treat the whole window as one single partition. All right. Notice I've got an order by here. The order by clause, which is inside the over clause, will determine the order in which the numbers are assigned. Before I actually illustrate with a query, I just want to quickly run a quick query on the product table so we can see the content. So I'm just going to run that so we can see. So this is the content of the products table. So it has 11 rows in total. So I've got a basic query here, and I've deliberately left out the partition by clause because that is optional. So I've not used a partition by. So let me run this query and see the output. So this is the output. So because we did not use the partition by clause, the row number function has considered the whole result set as a single partition. All right. The order by clause sorts the result set by the product ID. Therefore, the row number function assigns the integer values to the rows based on the product ID order. So I have modified the query, and this time I have included a partition by clause. So we're using the partition by clause to divide the window into subsets based on the values in the group ID column. So what's going to happen in this case is that the row number function is going to assign 1 to the starting row of each partition and increases by 1 for the next row within the same partition. By doing it this way, it makes it unique. The order by clause will then sort the rows in each partition by the values in the product name column. Okay, so let me run this query. You see the output. So let's give it a few minutes. Yep, so you can see what I mean. By using the partition by, you can see we have a different output. All right, so I'm going to do one more example, but this time I'm going to use a distinct with it. Distinct basically enables you to eliminate duplicate values. So you can see we have a lot of duplicates here, but if I use a distinct, it will remove the duplicates values. So I'm using the row number function this time with the distinct keyword. I'm using a select distinct, but I'm using it on a different table. I'm using it on the same table, but this time I'm ordering it by the price column. Okay, so let me run this and you see it will remove all duplicates values. So you can see here there are no duplicates, so all these numbering are unique. All right, before I wrap up this lecture, I just want to show you one more query example. Basically what this query is going to do, I'm going to use the row number function for getting the nth highest or lowest row. For example, to get the third most expensive products, so first we have to get the distinct prices from the product table and then select the price whose row number is 3. Once we've done that, notice here I'm using a subquery. So using a subquery basically uses the result of the first query, and then the outer query performs the operation on that query. All right, so what we're doing here in the outer query, we get the products with a price that equals to the third highest. All right, so let me run this and then you can see the output. It's a fairly long query, so this is the beginning, just in case you didn't catch all of it. That's the beginning, and it ends on line 24. All right, so I'll just run through that with you, and I'll tell you again what the query is going to do. It's going to find the third most expensive product. So what the query does first is going to get the distinct prices, that is the prices that are unique. It's going to get the distinct prices from the products table and select the price whose row number is 3. Then in the outer query, we get the products with a price that equals the third highest price. All right, so that's the beginning of my query, and that's where the query ends. So let me execute the query, and you can see the output, or just there's the result. So that gives you the third highest price. So in this lecture, I've shown you how to use the PostgreSQL row number function to assign integer values to rows in a result set. Many thanks for watching. If you have any issues and if you don't understand the lecture properly, please feel free to contact me. I'll be more than happy to go through that with you again. Take care and bye for now. Hello and welcome. In this lecture, I'm going to illustrate how the rank function works in PostgreSQL. The rank function basically is used to assign ranking within an ordered partition. If the values of the two rows are the same, the rank function assigns the same rank with the next rankings skipped. So if you've got two rows having the same rank, it will assign them the same rank, but it will skip the next ranking. So here is a query I have got to illustrate how the rank function works. So we've got the select statement. We're selecting these three columns from the table called products. All right, so we're selecting the product name, group name, price, and then we're performing the rank function over the partition. We're grouping it by their name and we're ordering it by the price. So this is the product table. I'm also performing a simple join on this other table called products_groups using the group ID. Okay, so when you perform a join, you can see this product group here has an identical column called group ID, and the products table also has an identical column called product ID. So it's easy to perform an inner join based on those identical ID columns from both tables. So let me execute this query by clicking on the lightning bolt. So this is the query. So you can see on the query that both in the laptop section, we've got this Sony Vaio and this Lenovo ThinkPad both occupying a ranking of 1 because they have the same price. So they've received the same ranking. The next row you notice is this Dell Vostro laptop. If you notice, the ranking has skipped because these two occupied the ranking of 1, so it skipped 2 and assigned this one a ranking of 3. So that's basically how a rank function works. Thanks for watching and bye for now. Hello and welcome. In this video, I'll be showing you how the dense_rank function works in PostgreSQL. So it's similar to the rank function in that it assigns ranking within an ordered partition, but the difference is that the ranks are consecutive. What I mean by that is that the same ranks are assigned to multiple rows and no ranks are skipped. When we did the rank function, whereby there is a tie where 2 rows have the same rank, it skips the next numbering and it skips the next rank and then assigns the next available one. With the dense rank, it doesn't do that, so it will have multiple, it can have multiple rows with the same ranking. So let's take a look at an identical query that we use for the rank function. This time I'm using it for the dense rank, and I've got the partition by and then the order by as well. And I've got a simple join here where we're joining using the group ID from this table, joining to the group ID of the other table. All right, so let me run this query and we can see the difference. All right, so you can see here straight away that when we did the rank function, whereby there's a tie, it will skip the next ranking and give the other ranking available. So you can see here, but with the dense rank, the ranking is not skipped. So you can see multiple rows can have the same ranking. So these two share ranking of 1 and so on. And then it doesn't skip, for example, it hasn't skipped to 3 like it did with the rank function. So that's the main difference between this function, the dense rank, and the rank function, in that the dense rank does not skip a ranking, while the rank function skips a ranking if there are rows that have the same ranking based on a criteria. In this case, the criteria is on the price. So these two have the same price, so they're both ranked 1. So that's it for this lecture on the dense_rank function. Thanks for watching. Bye for now. Hello and welcome to this video. In this video, I'm going to illustrate how the first underscore value function works in PostgreSQL. So what is the first underscore value function? What does it do? Well, the function basically is used to return the first value from the first row of the ordered set. So for example, if you wanted to return the lowest price per product group, you can use the first value underscore function to achieve that. So let me illustrate with a query. So this query here is going to use the first underscore value function to return the lowest price per product group. So it's just a basic query here. I'm selecting these 3 columns from this table here called products. Okay, and I'm applying the first value function to the price. And we're using the over clause here and the partition by, and we're ordering by the price as the lowest price group. So once the function has done its bit, it will display the lowest price per group. We're also doing an inner join using the group ID on the table called products_groups. So let me go ahead and execute this query, and we can see the output. So it's returned 11 rows. So you can see the query now is return the lowest price per product group. So let me just expand this column by dragging it. All right, so this is the lowest price per product group. Okay, so that's basically how you use the first underscore value function. Thanks for watching, and bye for now. Hello and welcome. In this video, I'm going to show you how the last underscore value function works. This window function works in the opposite way the first underscore value function works. So what does the last value function do? It basically returns the last value from the last row of the result set. So let me illustrate with a query. So I've got a query here, and this query basically is going to be used to return the highest price per product group. Okay, so we've got standard query stuff here. We've got to select the columns. We're using the last underscore value function over the price here. We've got the over clause. So these are all standard query stuff. So, but what is different here is this line 8 and 9. The range between unbounded preceding and unbounded following. What does that mean? Basically, by default, the window clause is range between unbounded preceding and the current row. So basically, the lowest possible bound, which is the unbounded preceding, refers to the first row. The current row is referred to as the current row, and the unbounded following refers to the last row. So the rows preceding and following the current rows are retrieved in using the n preceding and the n following, where n is the relative position to the current row. All right. So if you don't specify the between, the window function will implicitly end at the current row. So by using the unbounded preceding and following, basically indicates that unbounded references the first row, and then the unbounded following refers to the last row. So the rows preceding and following the current rows are the rows that will be retrieved. So let's run this query and we can see what the output returns. So there you go. You can see the highest here is showing the highest price per group. You can see it's also in order. All right. So with the lowest right at the bottom. So that's how you use the function called last underscore value, which is basically, I've used it here to return the highest price per product group. Many thanks for watching, and bye for now. Hello and welcome. In this video, I'll be illustrating how the lag analytic function works. So what does the lag function do? Well, with the lag function, it gives you the ability to access data from the previous row. So let's take a look at a basic syntax for a lag function. So this is what the syntax looks like. So you have the name of the function, which is lag, and in between the parentheses, you've got the expression, which can be a column or expression to compute the return value. And then we've got the offset. Offset basically refers to the number of rows preceding the lag function of the current row. The default value is 1, and here we've got a default. The default basically refers to the return value if the offset is outside of the scope for the window. If it's outside the scope of the window, then the default value is used, and the normal value for the default is null. Null basically means the value is not known. So I've got a query here that I'm going to use to return the prices from the previous row and also calculate the difference between the price of the current row and the previous row. That's basically what this query is going to do. So most of the stuff in the query here are familiar stuff. So I'm just going to execute that query, and then you can see the result. I'm just going to bring that up a bit so you can see. We can see we've got some null values there because the value is not known. So in this example, I have used the lag function to return the prices from the previous row and then calculate the difference between the price of the current row and the previous row. So this is the output. This is the current previous difference of this is the difference, and this is previous. I'm just expand that so you can see. All right, so this is current and that's previous. So that's it for this lecture on using the lag analytic function. Thanks for watching, and bye for now. Hello and welcome. In this lecture, I'll be illustrating how the lead analytic function works. The lead analytic function basically allows you to access data from the next row. So let's take a look at the syntax for the lead function. So it's similar to that of the lag. So we've got the lead function, and inside the parentheses, we've got these various arguments. So we've got an expression, which refers to a column or expression used to compute the returned value. Next, we've got the offset, which refers to the number of rows preceding the lead on the current row. Then we have the default value of the offset is usually 1. Then we have the default, which refers to the default return value. That is if the offset is outside the scope of the window. The default is null. So whereby the offset is outside the scope, the default is then used, and the value for that default is null. Null meaning you don't know the value. Value is unknown. So I've added this block of query here. Basically, this statement is going to use the lead function to return the prices from the next row and then calculate the difference between the price of the current row and the next row. Again, we're using basic stuff. We've got a simple join here where we're using the group ID. So let me execute the query and you can see the output. I'm just going to bring that up again so you can see. So we can see here we've got the prices from the next row, and it's also calculated the difference between the price of the current row and the next row. So this is a difference for the current row and this is the next row. So that's the next and that's the current. Okay, that's the difference and that's the next. So that's it. So in this example I showed you how to use the lead function to return the prices from the next row, and then which calculates also the difference between the price of the current row and the next row. So many thanks for watching. Take care and bye for now. Hello and welcome. In this section I will be introducing you to the concept of views in PostgreSQL. So I'll be showing you how to manage views. So we'll be creating a view, you learn how to modify a view and also how to remove views from the database. What is a view? A view is basically a stored query. So it's a select statement that is stored as a database object. A view can be accessed as a virtual table in Postgres. So basically views are a logical table that represents data from one or more underlining table using a select statement. A view is defined based on one or more table, and the tables are referred to as a base table. So you basically create a view from one or more tables known as the base table. So the views themselves do not store any data. They're just there to represent data from the base tables. However, there is a special type of view referred to as the materialized views. So they are the only type of views that actually stores physical data, and they actually refresh the data periodically from the base table. Materialized views have many advantages, and in that they are much faster to access the data, and you can also access the data from a remote server, and also it has caching features which makes it faster to return the data that is being queried. So that's it for the introduction to views. In the next lecture we'll be looking at how to manage views. So we'll start off by learning how to create a view in PostgreSQL. Many thanks for watching and bye for now. Hello and welcome. In this lecture I'll be showing you some of the useful benefits of using a view. Views can help you simplify complex queries. So with a view you can simplify the complexity of a query, because you can query a view which is based on a complex query just by using a simple select statement. Also, you can use views to hide sensitive information from a table. Okay, so you can hide sensitive information, for example, salary related information. You don't want that to be made available just to anyone, so you can restrict that. information using a view. Like a table, you can also grant permission to a view. So for example, you create a table, a separate view with sensitive data, and then you can grant permission to users that you want to have access to sensitive information or specific data. A view also provides a consistent layer even when the columns of the underlying table changes. You can query a view just like you query a normal table. So the syntax to retrieve data from a view is exactly the same as you would with a normal table. In this lecture, I briefly covered some of the benefits of using views. Many thanks for watching, and bye for now. Hello and welcome. In this video, I'll be showing you how to create a view in PostgreSQL. So we basically create a view using the create view statement. So let's take a look at a simple syntax. So this is a basic syntax for creating views. First of all, you start with the create view clause, followed by the name of the view, which you specify after the create view clause. Then you put a query after the as keyword, which is this as keyword. And a query basically can be a simple select statement or a complex select statement that even includes various type of joins. So first of all, to illustrate how to create a view, before we do that, this is just a simple query. A query is kind of like a complex query to show you different types of joins. So we're joining various tables together to create a query. So one of the advantages of views, for example, if you are querying data from multiple tables often, and you're going to be doing the same thing often, then you are better off creating a view from that statement. So that's what we're going to do, but I just want to show you what the complex query looks like before we create a view from it. So we are using our sample database, which is a DVD rental, and we're going to take a look at 4 tables. So I'll start with the customer table here. We've got a customer table, and which basically stores all the customer related data. So I've got this in my select statement here. I've got the customer table here, and from the customer table, I am going to use the customer ID column and the store ID column, which is these 2 columns here. Notice I've got CU is just an alias. You normally specify an alias inside the from. You can see my from here. This is where I define the alias that I'm using here. So I'm taking 2 columns from this table called customer. I've got another table called address. If I bring that up, you can see address, and these are all the columns for my address table. The address table basically stores addresses of the customers. So from the address table, I'm going to use 3 columns. The address, which is this column here, the postal code, this column here, and the phone. So I'm taking 3 columns from the address. So you can see I've represented it here, and on the I'm using an alias A to represent address. So it tells you that this address is coming from the address table. So these are the 3 columns I'm picking up from the address table. So another table I want to use is a table called city. This is a city table, which basically stores data related to cities. And from the city table, I'm only going to use 1 column, which is the city column. So you can see here where it says city, I'm only using 1 column, which is city. Finally, I've got a table called country, which basically stores data relating to countries. And from the country table, I am using just one column here, which is the country column here, which is specified here. You can see I've also used a case. A case expression basically is when it will evaluate the script based on certain condition within the case. So this is the case here basically. So when this is it meets that condition, then it will execute, whatever code is there. So that's what this case expression. But you can see how complex this query is, because I'm joining 3 tables together and I'm using other expressions as well, like case, when, else, and so on. So I'm going to execute this query so that you can see the output. Just click on that and that should show me the output. Okay, so it's returned 599 rows. So we see how complex this is. So now I'm going to create a view from this complex query, and the view will give me a complete customer data, which would be a combination of data from several tables. So I've added another query here. So this is the query that actually creates a view from the multiple tables. We are using joins here to represent the data from multiple tables. So you can see here we started with the create view statement. I've created the view here and I've called the view customer_master as the name, and basically it's a lot similar to the previous query, which is this query here, but not as complex as it. Okay, it's a bit similar but not as complex. So we're using the create view statement to create a view called customer_master, and then we are grabbing basically the same columns I mentioned before in the previous illustration of the complex query. So using the same column names and so on, and we are also using the join as an expression. So the key thing here is that we don't have to, once we've created this view, we don't have to do a join each time we want to query data from this table. So by creating a view, it gives us a more complete customer data. Okay, so all you need to do is just run the query and it will execute the view. So this is the main difference between this and this query, in that the view, we can save the view as a table. It is as a virtual table. So anytime we want all this related data, we just run the view. So let me execute this query, and you can see, I'll click on that and we should get the same total here. Okay, so it tells you query returned successfully. So this actually creates the view. It doesn't execute the statement, but if I wanted to run this view now, I will query it just like you would a normal table. So the view has been created. If you look on the left hand side here, you should see a section for views. So if you expand that, you should see the view we've just created. You can see we've got a view here called customer_master. If I expand that, you can see the columns. We include all the columns. All these columns are a combination of columns from all the tables we've used in the view. So to execute the view, you just execute it the way you would do a normal table. So I'm just going to do a simple select statement here, which is this one I've written here. So I'm selecting star, means it will get data from all the columns from this view called customer_master. So I'm highlighting it to execute it, and then you can see the output. You can see it's giving me the same output when I ran the complex query. So it's giving me 599 rows. So this is a neater way of reusing a query that you would otherwise normally have to write all the time. So this saves a lot of time writing or reconstructing the data from each of the tables. So anytime I want this type of related customer information, I just come to my view and execute that. So that's basically how you create views. Hello and welcome to this video. In this video, I'll be showing you how to modify an existing view. So what we're going to do, we're actually going to modify a view by appending an extra column to the view. So in order to change a view, you have to redefine the query, and this is the syntax. So we'll basically start with the create. We are creating or we are replacing, followed by the name of the view, and then you specify the query. So what I'm going to do, I'm going to add an extra column to the view we created in our previous video. So I'm going to add an email column to that view. So I'm just going to run a quick select statement so we can take a look at the columns that we have in the view. So that's the name of the view we created in our previous video. So if we look under the view section here, you can see the views listed here under customer_master. So I'm going to run this query and we can see all the columns we have at the moment. So if I expand the view, you can see the columns in the view. So these are all the columns, which are the columns that are displayed here. So the plan for this lecture here, I'm going to change this view by adding an extra column to the end. So I'm going to append it. So it'll be another column, and the column I'm going to add is going to be a column for an email here. So I'm going to add that. So let me add the script that will action that. So I've added a script. This is a query, and you can see here the previous view ended with this column here called seed, which is this one here. So I've had to put a comma there and added another column for the email. You can see this is the email from the customer table. CU basically is the alias I've given to the customer table. So that's what I've used here, CU, to represent the email. So this email column is coming from the customer table. So notice I've used the create or replace. So I notice I've given it the same name. All right. So what it will do, it will replace this view. That's what it's saying, either create or replace. So let's check that out and execute this query. We'll see what happens. So you can see it says query returned successfully. So it has created the view. So now if I run the select statement again, I will expect to see an extra column for email appended to the previous view. So this is the select statement I'm using to query the view. So I'm going to run it by clicking on this lightning bolt, and you should notice an extra column at the end for email. So there you go. So we have been able to modify an existing view by appending to the view. You can also change the definition of a view by using the alter view statement. You can see here I've used the alter view statement. So basically by changing the definition, you can, for example, you can rename a view. So if I wanted to change the name of the view from the current name, which is customer_master, to customer_info, this is the statement I would write to change the definition of the view. Before I wrap up this lecture, I also want to quickly cover how to remove a view in PostgreSQL. To remove an existing view, you basically use the drop view statement, which is this statement I've highlighted here on line 8. So you start with a drop view, and you got to use, you're using the if exists, so that if it will check first if the view exists, then you indicate the name of the view. So you specify the name of the view that